Hi, Algebra 1 students. We're on lesson 76. And it's a specific type of problem called consecutive integers. Don't let that scare you. Consecutive integers. Integers are counting numbers and zero. So it means no fractions, no decimals, no percents. Let that be good news. Consecutive means in a row, right? And here's the way the problems sound. Find three consecutive integers such that the sums of the first and the third is 146. Okay, so by consecutive integers, let me help you visualize it. Here's a number line. It doesn't matter where we are on the number line. Find three numbers in a row. So maybe they're 4, 5, and 6. They're -1, -2, oh no, that wouldn't be that way. It'd be -3, -2, -1. Me and my bad number lines again. It could be any, but the point is that they're on the number line and they're not fractions and decimals. They go in a row. The key to setting up these problems is doing the variables. It says find three consecutive integers. So what we're going to do is we're going to call the first one n. Then for the second one, instead of using a different letter, we're going to say n plus 1, right? Because that would get us to the next jump. That will be the second one. And then guess what we're going to do for the third one? N plus 2. This is the secret to these problems. Once you understand how to set up the variables, then the rest of it becomes fairly, and I do say fairly straightforward. Find three consecutive integers such that the sum means adding, of the first and the third, so we know we're going to have to add the first and the third, is always means equals 146. Okay? The sum of the first and the third is 146. So the first is n. We add the third, n plus 2. And the total is 146. The sum of the first and the third is 146. That's the second hard part, is setting up the equation. Algebra is easy. Add like terms. Swim, little fishies. Best friend, go home. It's a school night. N equals 72. Okay? That's the first of the three consecutive integers. If we want to show them all, then we have to add 1 and add 2. So our answer looks like this: 72, 73, 74. We don't have to put them in parentheses because they're not an ordered pair, but we were told to find three consecutive integers, and there they are: 72, 73, and 74. Beautiful. Let's do another one. I'm having so much fun, are you? Example 76.2. 76.2. I put the emphasis on the wrong number. The emphasis. Find three consecutive numbers such that, okay, here we go, hold on to your hats. Twice the sum of the first two is 2 less than 3 times the third. Okay, mind blown. Let's break that down. Three consecutive integers. First, I'm going to set them up so I know what I'm doing. That's the first, that's the second, that's the third. Okay. Twice the sum of the first two. Okay, so twice the sum, that means I'm going to have to add in here. Sum of the first two, n plus 1. I could put parentheses around that if it helped me. I'm adding the first one and the second one. It's your call. Twice the sum of is 2 less than, I'm going to ignore the 2 and I'm just going to write less than 3 times the third. Twice the sum of the first two is less than 3 times the second. Did I do that right? No. No, this is right. This is the third. I'm sorry. I'm getting confused. Let me say it one more time. Twice the sum of the first two, n and n plus 1, is less than 3 times the third. We have to put the third in parentheses because we're going to have to multiply and distribute. Okay, but we still have an inequality here. This side is smaller, this side is bigger. Let's subtract 2 from this side. And when we rewrite it, we'll get that better in there. So now it's equal, because I fixed it. Okay, this becomes 2n plus 1 inside the parentheses. So I'm going to distribute that, and I'm going to get 4n plus 2 equals, distribute this, 3n plus 6, and then minus 2. This little dude is just hanging on the back end of this side of the equation. He's not part of the distribution. Okay, ready to swim some more fish? Let's do it. First we'll add the like terms. 6 minus 2, that's 4. So let's bring the 2 this way, and the 3n to the left. Make sense? I moved him across. I added like terms, then I moved that across, and then I moved that across. You're gone, you're gone. 4n minus 3n, oh, I like it, equals n. And then 4 minus 2 is 2. So that tells us that the first of the 3 consecutive integers is 2. So sometimes I show the answer like this. 2, 3, 4. And then I would do my box like that. That's another way to show the answer. Yeah? The equation we used to set it up got a little crazier, but we just have to slow down and use our math skills and we'll be fine. One more, for example, 76.3. Find 4 consecutive integers. Okay, John, fine. n plus 1, n plus 2, Brady, wait for it, n plus 3. Now we have 4 consecutive integers, such that, ready, 6 times the sum of the first and fourth, the first and the fourth, 6 times the sum of the first and the fourth is less than 10 times the third. Of the first and the fourth is less than 10 times the third. Notice we're not even using the second one in the equation. That's fine. You don't have to use every single one of them. It works out fine. Okay, 6 times the sum of the first and the fourth is less than 10 times the third. Okay? Now, that's an inequality. We have to balance it. It's 26 less. So again, let's see, the inequality says this one's smaller and this one's bigger. So let's subtract 26 from that side. Add these like terms, 2n plus 3. Then we can distribute that, and we can distribute that. He's not part of the distribution. 12n plus 18 equals, change that to equals 2, 10n, sorry, I was busy doing the second one first. 10n plus 20 minus 26. Equals 10n minus 6. Subtract 10n from both sides. This is just algebra. Subtract 18 from both sides. 2n, cancel, cancel, equals minus 24. Okay, it looks weird. At first we think, minus sign, what? But it's fine. We can have negative numbers. It doesn't matter. Divide both sides by 2, and we get n equals negative 12. What does that mean? That means that the first of our numbers is negative 12. Now, remember that, let me flip over and show you on our picture. the first number we calculate is always the number that's on the far left side of the row on the number line. So in this case, let me just cross off some of these numbers. We just calculated that the first number is negative 12. So just visualize it that as we're creating the other numbers in our consecutive row, we're going to be moving toward the right. We're going to be adding one each time. So when we're in negative land, we're going to be moving closer to 0. Does that make sense? And we can see it again here. We're adding 1. Well, negative 12 plus 1 equals negative 11. And negative 12 plus 2 equals negative 10. And negative 12 plus 3 equals negative 9. That can be just a little bit confusing because sometimes we want to go negative 12, negative 13, negative 14, negative 15. No, that's moving the wrong way on the number line. We want to be moving toward the right. Okay, there's our third example. This time we had 4 consecutive integers. We did not let that dramatize us. We only used the first and the second and the fourth. We didn't use this third one, or I'm sorry, we didn't use the second one in our equations. That's okay. Just do whatever the words tell you. Lesson 76 is history. Thank you, students. Hopefully I will see you on next Tuesday.